Question 5, page 256, carrying on with transforming graphs. It's getting a bit more tricky because if you look at the graph of y equals 1 over x, there are two branches. There's this one in the first quadrant right there, and this one in the third quadrant like there, and that's the characteristic shape of the graph of y equals 1 over x. So what we're going to do is sketch each of these graphs here, y equals 1 over x plus 1, etc, etc. So it's 6 graphs, 6 screenshots, 6 little sketches, and in each case got to describe the transformation needed to get each of these graphs from the original graph of y equals 1 over x. So if the graph is originally y equals 1 over x, effectively I'm playing with y equals some function of x, and that's my original function of x, and each of these are going to be the fx plus 1, for example. Now if I look at the very first one, it is in fact the original function y equals 1 over x, the original function of x plus 1, and as you may recall, this plus 1 raises the graph in the y direction by 1 unit. So if I can imagine, for example, I've got the line y equals 1 like that, label it such, that's the line y equals 1. What's going to happen is this is going to be raised 1 unit, so that will go up to there, and the point 1, 1 will go to point 1, 2. So we're looking at a transformation something like this. Okay, so it works towards touching the line y equals 1, but don't actually do it. And here again, the point minus 6, 0 is not exactly minus 6, 0, obviously, because this part of the branch will tend towards touching the x-axis in the negative direction, but it's going to be raised 1 unit, so try and get as close as we can, and something like that. I think, yeah, it's really hard to draw, so I think it's going to be something like that. Alright, okay, let's just raise it 1 unit, not perfect, can't make it look brilliant really, but I'm going to try and make it a little better than that. Just try that again. So touch that and then come across the y-axis as normal, just skim across it like that, and off we go. That's not a bad representation. Describe the transformation. So it's going to be a translation of y equals 1 over x using the vector 1, 0. In other words, sorry, not 1, 0, got it backwards. It's 0, 1. So we're going 0 in the x direction and 1 straight up in the vertical y direction. Okay, so there we go, plus 1 unit up in the air. That's what we've done. So we're translating the original f of x, which is 1 over x, using vector 0, 1, and up it goes. Okay, so I've just described that. Okay, next one, we've done that one. Here we go, y equals 1 over x plus 2, in other words, raise the whole graph plus 2 units up in the y direction. So here we go, let's lift it up 2 units, so 1, 1 becomes 1, 3, and I suppose that looks a bit like 6, 0, so that will be like 6, 2. So if I've got the graph of y equals 2, I'm going to sort of skim along that, basically, do this like that, and draw the transformed graph. So it's going to look a bit like that. That's a definite point there. Come across and just work towards that. In the same way, this graph will be lifted, almost touching the line y equals 2. Let's just label it. And in terms of simple sketches, that's good enough. Okay, I've clearly lifted the thing up 2 units, so from there to there, plus 2, from 1, 1 to 1, 3, plus 2 units. So how did I transform that? It's a translation of y equals 1 over x, and I'm using the vector 0 along and 2 straight up. Okay, that's all there is to it really. Translate it 0, 2 units and lift the whole graph up by 2 units parallel to the y-axis. Alright, so that's that one done. Next one, straightforward. Y equals 1 over x minus 1, so that's my original f of x minus 1. Essentially drop the graph 1 unit down. Alright, so we're looking at skimming towards the line y equals minus 1. Did I label the other one? I did. So there's y equals minus 1. So 1, 1 becomes 1, 0. That's a key point there. So we're looking at something like this. Working towards touching y equals minus 1 but never actually reaching it. And of course this will drop in the same way. So almost touching y equals minus 1 and working down like that. Okay, so that's it. Another transformation, clearly so. So it's a translation of the original y equals 1 over x, and I'm using the vector 0, minus 1. In other words, I'm dropping it straight down by 1 unit. Okay, very, very straightforward. Next one, much less straightforward. If I look at it carefully, I've got my original y equals some sort of function of x, and that's defined as 1 over x. And if I look at this graph here, I've got y equals 2 over x. Essentially, I've got y equals 2 multiplied by my original function of x. So let's just call that 2 times 1 over x. Can you see that? So 2 times 1 is 2 over x. Effectively, I've got y equals a f of x. My original function is 1 over x, and essentially my a is the 2. If you recall, that means multiply the y coordinate by 2, so therefore I've got to stretch in the y direction using scale factor 2. Let me just write that first. Stretch in the y direction by scale factor 2. Alright, so that's quite straightforward. So 1, 1 becomes 1, 2. What else should we do? 1 minus 1 becomes 1 minus 2. So that's a valid point, isn't it? Let's see if I can get some answers from here. That'll help me quite a little bit, I think. Yeah, that's what's going to happen. What about this one? Quite hard to do, really. 2 half becomes 2, 1. Because if that's approximately 2 half, it should be, because 1 over 2 is a half, so it's correct. The y part of the coordinate will be 1 half. So that's 2, 1 half. If I multiply the y coordinate half by 2, half times 2 is 1. So I've effectively got something like this, passing through those two key points and doing that. In the same way, I'm going to get something like this, passing through that key point. And the net effect is to push the graph in that direction away from the axes. Okay, that's what happens. So there it is. That's the transformation drawn. I think that shouldn't be touching, really. I think this bottom one's a lot clearer. So let me try and make that better. Oh, okay, that's all right. Very good. So again, I've taken my original f of x, my 1 over x, and pushed it away from the axes, and therefore moved it over to the right. This one, I've taken this branch in the third quadrant and moved it here, as if to say I'm moving southwest, going this way, and moving this part of the branch away from the axes again. Effectively a stretch in the y direction using scale factor 2, and that's all that is. It's great. Next one, really tricky, I think, and that's this one just here. Any more? Yes, there's one more, of course. Let's study this one. Here's my original y equals a function of x. My transformation is that one, so y equals 1 over 2x. If I decode that a little bit, I've got y equals 1 half of 1 over x. Okay, it's slightly different to this one, because here I'm multiplying the previous one. I'm multiplying by 2 to get that. Here I'm effectively multiplying by a half. So that part is my original function of x. There it is right there. And I've effectively got y equals a f of x, just like previously here with the y equals 2 over x. But here my a is worth a half. Therefore it's still a stretch in the y direction using a scale factor of 1 half. So I've got to multiply the y part of the coordinate by a half. So if I've got 2, 1, sorry, if I got 1, 1 for example, this part I multiplied by half, therefore it will become 1 half. So 1 half is about there, and effectively what I've got is something like this. It comes on the inside of the function and does that and works towards the x-axis as shown. In the same way it'll do something like that and come towards the y-axis like that. So whereas before I had a stretch away from the axis, here I have a stretch in towards the axes. Can you see that? Let's just study this one. So this one gives me a stretch away from the axes, as in the previous screenshot. There it is, pulling away. And here I have a pull towards the axes using this function here. It's slightly different. Well, it's the same general function, AFX, but of course the A is only half. So when I multiply the y coordinate by a half, it's going to pull in a bit more, isn't it? So that's the effect, and that's how the sketch would look. And the last one is quite easy. Drawing it won't be brilliantly easy, but here we go. Just take a good look over here. That's the last one. Reiterating, this is the general function y equals f of x, defined as 1 over x. Here I've got y equals minus 1 over x. In other words, I've got y equals minus the function of x, and you may recall that means reflect the function y equals 1 over x. Let's just get that f done properly. Function 1 over x in the x-axis. Do you remember that? So minus the function of x reflected the x-axis. Actually, it's quite nice to draw. So this part reflected in the x-axis produces something like this. Again, working towards the x-axis, coming from the negative direction, and this part gets reflected above the line, above the x-axis here, and it will look something like that. So that's the mirror image, and that's me taking off. Oh, took off a bit soon there. Let's just do it again. Quite hard to judge, honestly. So come over here, up we go, and take off, and there it goes. Beautiful. So the blue line is the transform function, and that's y equals minus 1 over x. How did I do it? I reflected the function y equals 1 over x in the x-axis. That's what I did, and that's it. I'm very happy with that, and I'll catch you later for question 6.